Here you have what is known as a unit circle, and it's called a unit circle because we have a circle where the coordinate that you hit on all of the axes has a unit of 1, meaning starting from the center of the circle, which is our origin, and moving outward to the edge of the circle, this is a radius of 1, as well as all of the other points that we move to the edge of the circle has also, we consider, a radius of 1. So this coordinate right here is the coordinate 1, 0, okay, 0, 1, negative 1, 0, and then down here is 0, negative 1. And so what we want to do is we want to be able to look at how special triangles lay on the unit circle to help us find the other coordinates that are around the circle. So things to remember is that when you're dealing with degrees, here on the x-axis, which is always our initial side, this is always 0 degrees. And when we make one full rotation, will be 360 degrees. And when we are in radians, it's 0 radians or 2 pi for one full rotation. All right, so all of these values are here at this particular point. Right. And so we're going to forget about the ones in the quadrants for a minute and just label the ones on the axes. Up here, we have 90 degrees, right, which in radians is pi over 2 radians. Over here, we have 180 degrees, which is pi. And down here, we have 270 degrees, which is 3 pi over 2. So now what we want to look at is we want to look at how these special triangles, again, lay on our unit circle. And so first thing I'm going to do is I'm going to connect these first dots right here. And these first markers, these first lines, these are 30-degree increments. All right? And so when we have our 30-degree increments, it doesn't matter what quadrant it's in, that central angle is always going to be 30 degrees. So this right here is considered from my initial side to a terminal side 30 degrees. All right? And so instead of writing it down in here, right, a central angle has the same measurement as this arc. So 30 degrees on the inside is the same thing as 30 degrees here on the outside. So I'm going to label it. That is also the same as a pi over 6 increment. And so I want you to see that this little arc is the same as this little arc, and all the way through these little arcs. All right, so between the x-axis and that little side has 30 degrees. And so everything we do with increments of 30 are going to be the same for all of these same areas. So what I want to do is I want to draw a perpendicular line, and I want to visualize a special right triangle right here. So in a special right triangle, right, again, we have a hypotenuse of 1, and that is because going, again, from the center to the edge of any part to the circle has a radius of 1 when you're on a unit circle. And so if I have 30 degrees, and I have a hypotenuse of 1, we've been solving these a lot, that if I set this side equal to 2x, that means that this side right here has a length of 1/2, and then the side opposite the 60 has a length of root 3 over 2. And so what happens is that if I think about what this coordinate is, it has an x value of root 3 over 2, and it has a y value or a height of 1/2. So I'm using the heights and the legs of the triangles to find the kind of like the length going along the x-axis and the y-axis to get this coordinate. All right, so that's the coordinate of this point when I'm on the unit circle at 30-degree increments. Now, because this triangle is the exact same as the triangle over here, all I'm really doing is making a mirror image and flipping it on this side. The length along the x-axis of my triangle will still be root 3 over 2. However, because I'm on the negative side of the x-axis, my length is going to actually be negative root 3 over 2. So you have to remember what happens when you're in that quadrant, that x coordinates on this side are negative, but y coordinates are still positive. Right? And so this gives me the length and the height of this particular coordinate. And so this is going to be a negative root 3 over 2 positive 1/2 coordinate right here. So you can see that this coordinate is the exact same one when I flip it over the other side of the x-axis, just the value changes because in this quadrant, x values are always negative and y values are always positive. And so now, as I label this one as a 30 degrees, I want to look at how I'm going to label this coordinate. So if this is 30, 60, 90, 120, this is the same as 150 degrees. And that is also the same as 5 of the pi over 6 increments to get there. All right, so we want to be able to have a degree measurement, the radian measurement, and the coordinate for this point. And so let's flip the triangle upside down. Again, we can see that it still has the x value of negative root 3 over 2, but now I'm going into the negative zone for y's. And down in this quadrant, y values are always negative. And so this coordinate is negative root 3 over 2, negative 1/2. Right? And again, if I think about adding a 30-degree increment, that's the same here as 210 degrees, or 7 of the pi over 6 increments. Now let's come over to this triangle and let's flip this one upside down as well. So again, this has a positive root 3 over 2 for the x value, but again, it goes down to negative 1/2 to get to the y coordinate. And so this is root 3 over 2, negative 1/2. And I'm not going to go down negative 30. I want to continue around my circle here. So this is 330 degrees, which is the same as 11 pi over 6.